So hello everyone and welcome to part 2 of the organic chemistry 1 marks question solution of GATE 2021. So in this question we can see that this is the setup of a Diels-Helder reaction. So Diels-Helder reaction is actually a very known named reaction in pericyclic chemistry. So here the starting materials are very important because the orientation of the diene is very important, and also the orientation of the dienophile. So as we can see here that the diene that is present has got an OMe group which can actually push electrons and cause a delta minus charge. Also the presence of OSIMA3 facilitates this process. In the dienophile we have the C triple bond N which causes a delta positive charge. So as we can see, the orientation of the starting materials, that is the diene and the dienophile, should be as such during the mechanism. And let us see the electron arrow pushing that is happening here. So the orientation should be as such that 1,4 substitution happens. So that is OSIMA3 is present, and in the fourth position is actually CN is present. So it is like a parallel position, we can say. So as we can see here that in the parallel position CN has formed, and there is OSIMA3, and also aqueous acid has been provided in the second step. So what happens is that the OMe group is protonated and the OSIMA3 group hence undergoes hydrolysis, and in a concerted reaction mechanism we actually get the final product. And in the final product we actually get a C double bond O, and which is conjugated with a C double bond C, and there is also a conjugation with CN. So yeah, so CN group is not under conjugation, but yeah, so this is the answer. Yeah, okay, so thank you. So let's go to the next question. So in the next question, what has been provided to us is that they have asked us to find out the reagents that are required for the conversion of an alkyne to an alkene. So hex-3-ine to E-hex-3-ene. So E means they want the trans form, that is the opposite of the endogen form. So the reagents that have been provided by them is the H2PDBSO4, Bu3SNH, lithium and liquor NH3, and LiAlH4, lithium aluminum hydride. So for this reaction, let us first check out the formulas that of hex-3-ine and E-hex-3-ene. So as you can see that the hex-3-ine, that is with the numbering of the carbons, we can see it looks something like this, and it is needed to be converted to the E-hex-3-ene, that is the trans form of the hex-3-ene. So for this solving this question, let us first look at the first reagent, which is actually a pretty known reagent, which is known as the Lindlar catalyst. So the Lindlar catalyst is known for converting alkynes to the cis alkenes or the Z forms. That is the where the the two higher priority groups or the bigger groups are actually in the same side. So here we can see the reagent that is happening, the reaction that is happening. So we get the cis alkene, and the lithium liquor NH3, which is basically the BARC reagent. So this is the reagent that is used in BARC reduction. So this helps us to convert the alkyne to the trans alkene. So this lithium liquor NH3 actually converts the hex-3-ine to the E-hex-3-ene. Lithium aluminum hydride cannot reduce the alkynes, and also Bu3SNH does not reduce alkynes, and hence the answer for this question is lithium liquor NH3, which is also a reagent that is used for the BARC reduction reaction. So as we can see that for this question the answer is lithium liquor NH3 as the reagent to convert hex-3-ene to E-hex-3-ene, hex-3-ine to E-hex-3-ene. Yeah, so thank you, and follow part 3. And as I always say, keep practicing, keep writing organic reactions.